The place I'm going to introduce now is a planet called J1407b. This planet orbits a star system called 1SW J140747, 93 to 3945. To make it easier for both you and me, let's call this star MI214-7. MI214-7 is a very young star with a spectral type of K0 and an age of less than 16 million years. This planet is located in the direction of the constellation Centaurus and is about 64 light-years away from Earth. It is quite dark and cannot be seen with the naked eye, only through a telescope. However, this star has only recently begun to twinkle, and it may shine even brighter in the next 1 billion years. If that happens, its spectral type will change to F4G, and it will become similar to the Sun. The star's mass is about 0.9 times that of the Sun. We can say that it meets the conditions sufficiently. J1407 itself is not a very rare star. In the past, it drew some attention among scientists because of its youth. Studying stars like this could greatly help us understand what the Sun was doing 4.5 billion years ago, and could also help solve many mysteries related to our solar system. However, since there are many stars like this, the degree to which their number increases or decreases is not very important. If we have to name something much more interesting, it would be J1407's only planet, J1407b, which can be measured. This planet was discovered when data on the star's brightness was examined for several years starting from 2012. Before its discovery, continuous photometry was observed in J1407, and it was found that this photometry was caused by the transit of a large planet, as experts had guessed. This is called the transit method. Through this method, many exoplanets have been discovered in various star systems, and this time, it did not disappoint the expectations of astronomers. As researchers investigated the newly discovered planet, dubbed Saturn's reinforced plate, they couldn't help but be amazed. First of all, it was revealed that this planet has an enormous mass, 20 times that of Jupiter. To give you an idea of how heavy that is, consider this fact: Jupiter is heavier than all the other planets and moons in the solar system combined. If you were to break down Jupiter's mass into material, you could make 6,356 planets the size of Earth. Strictly speaking, celestial bodies of this size are more likely to be brown dwarfs rather than planets. Brown dwarfs are objects that fall in between planets and stars in terms of their mass. While they have enough mass for nuclear fusion reactions to start in their interiors, they don't have enough mass to sustain them for long. To generate a complete reaction, there isn't enough mass, so a celestial body is born that doesn't ignite and hardly shines. It simply continues to emit that flow until it loses its light and cools for millions of years. Scientists are still debating whether to classify brown dwarfs as stars, planets, or special geniuses. However, at the moment, the existence of nuclear fusion reactions in the protagonist of this video, J1407b, has not been confirmed, so it will be referred to as a planet here. While investigating J1407b, it was discovered that the planet has a massive ring. Is it like Saturn? Did you think that? But no, it's completely different. Compared to Saturn, this planet has a much larger mass, and its ring is equally impressive. The total mass is equivalent to that of the Earth, and the outer diameter of the ring is about 90 million kilometers. This is 640 times larger than Saturn's ring. It is located at a distance just 18 million kilometers short of the distance between the Sun and Venus. Because of this, planet 1407b is sometimes informally referred to as Saturn's reinforced plate. Scientists have discovered several gaps in this large ring, with the largest gap located 61 million kilometers away from the planet. Astronomers speculate that a giant satellite with a mass comparable to that of the Earth may be orbiting in this region, dispersing the particles that make up the ring. Therefore, other gap location may also match areas where smaller extraterrestrial satellites are present. The 1407b ring itself is already quite impressive, but the mystery of this strange planet does not stop there. Moreover, this planet appears to be in a highly skewed orbit around its star, and there are other unusual features as well. Based on estimates, the orbital period can range from 3.5 to less than 14 years. Planets with both a skewed orbit and a position far from their star typically indicate a captured planet rather than a planet born in the stellar system. The fact that there are no other planets in the planetary system of 21407b may also be due to the presence of a giant, invading planet that may have chased away the other planets. Similar cases have been observed within the solar system, such as Neptune's only giant planet, Triton, which is also thought to be a captured celestial body that expelled all the other large moons except for a few. In such cases, the ring orbit of 1407b would inevitably become unstable, and the ring would disappear due to a sudden decrease in gravity. Therefore, scientists have built models to repair the planetary ring system. And we succeeded in solving this puzzle. The experimental results showed that for the ring to be stable, its rotation direction and the direction of the orbit in which the 1407b planet revolves around the star must be opposite. The properties of the ring surrounding 1407b have not been fully explained yet. Although there are rings around any large planet in the solar system, most rings are made up of tiny rocks or crystallized snow that are too small to even become a satellite. Saturn's rings are the largest and most spectacular. On the other hand, this giant planet is different from others. It is uncertain whether it is a captured protoplanet or was born in the same gas group as the parent star, but the planet is very young like the star. Perhaps, the ring of this planet was formed in a primitive planetary nebula, or more precisely, in a primitive satellite nebula, or its debris. It seems that the particles in the ring are still colliding and gathering, gradually forming satellites. In places where this process has already been completed, extraterrestrial satellites have formed vertical orbits and are cleaning up debris, but most of the process is still ongoing. Recently, it was revealed by a scientist that a planet called 1407b does not exist, causing a stir among scientists. The star known as the host of this planet is simply a regular variable star whose brightness frequently changes, and it is speculated that the misunderstanding of this decrease in brightness might have occurred. That's it for today's video. Thank you for watching until the end. For those who are disappointed with the conclusion, don't worry, not all scientists support this hypothesis. The behavior of 1407 is different from that of a typical variable star. So, is it still simpler to believe that a giant planet exists? My 1407b may not be the end yet, as most scientists believe this planet exists. Therefore, it has not been removed from any list yet. If we continue to investigate the remarkable features of this giant planet, we will discover more secrets. To do that, please subscribe to our channel and like the video.
They're out there, lurking in the vastness of space. Planets so weird, even science fiction could not foresee them. For the first time ever, scientists are discovering alien worlds beyond our solar system. Places where ice is hot and rain is made of iron. They are uncharted, unearthly, and unpredictable. And somewhere, hidden among these strange new worlds, scientists seek the greatest discoveries of all. Planets like ours, alien Earths.
35 seconds. Let's go. Storage tank press closed.
March 6, 2009.
22 seconds.
Later, GN2 pressure go.
This Delta II rocket is going through its final pre-flight check.
71.3.
Drop 1.
Engine start, 1-0, and liftoff.
It is the start of an extraordinarily ambitious mission. The Kepler Space Observatory is hunting for planets like Earth within a region of 100,000 stars. It is the culmination of a journey that began more than a decade ago with one of the most profound scientific discoveries ever made. (1995). Swiss astronomer Michel Mayor and his team make a routine observation of stars in the constellation Pegasus, located 50 light-years away. But the instruments show something strange. One star is violently lurching and wobbling.
What we discovered, it's one of these stars have a velocity changing with time.
What is powerful enough to disturb a star the size of our sun? Mayor offers a radical answer: a planet. But no one has ever seen a planet around another sun-like star.
Problem in detecting planets around other stars is that as a planet orbits a nearby star, that planet gets lost because of its feeble light in the glare of the very bright star.
In spite of the odds, Mayor relies on his data and is convinced the wobbles are caused by the gravitational pull of an orbiting planet.
When I read this claim from Michel Mayor, I was very skeptical. There had been many false claims of the first planet ever discovered around another star, and I thought to myself, oh boy, here we go again. So I decided to observe the star on 4 consecutive nights. And stunningly, the star was shown to wobble exactly as Michel Mayor had said.
Michel Mayor and his teammate Didier Queloz announced their discovery. It rocks the scientific community.
They had found for the first time reproducible, confirmable evidence of the existence of a planet around a sun-like star.
Officially called 51 Pegasi b, the planet is nicknamed Bellerophon, in honor of the Greek hero who tamed the winged horse Pegasus. It is a planet that breaks all the rules. Bellerophon roasts in the blazing starlight at temperatures of roughly 1800 degrees Fahrenheit. It is nearly 150 times more massive than Earth and is a gas giant like Jupiter.
A gas giant is a planet made mostly of hydrogen and helium. Only the outer layers are gas, but inside, hydrogen and helium is compressed to huge, huge, huge pressures. It doesn't resemble a gas at all.
Unlike anything found in our solar system, this is an entirely new class of planet, what scientists call a hot Jupiter.
If you go to Hawaii and see the lava flow there, that's how hot a hot Jupiter is. It's very, very hot.
The Earth is a comfortable 93 million miles away from the Sun.
These hot Jupiters are roughly 100 times closer, and so the amount of sunlight that they get is 10,000 times larger.
If this represents a star, and this a hot Jupiter is 3 to 4 stellar diameters away from the star. So that would be 1, 2, 3. This is how close a hot Jupiter would be to its star. Hot Jupiters are tidally locked. They present the same face to the star at all times, just like the moon does to Earth.
It's going to be permanent daylight on one side and permanent nighttime on the back. If I were stuck on a hot Jupiter, I'd want to be on the back side and hope that some of the heat from the front side facing the star would make its way around the back.
The variations in temperature make Bellerophon's atmosphere extremely windy. The wind howls at thousands of miles per hour, far beyond anything we could ever withstand. The heat blast guarantees water vapor cannot exist. But that doesn't mean there is no rain.
It's far too hot for water liquid clouds to form here. But instead, these clouds would be made out of iron.
Iron vapor can exist at temperatures much higher than water. And because of that, things could get a little messy.
You better have an umbrella that's pretty sturdy, because the iron is going to start coating your umbrella very rapidly and making it extremely heavy and just crush that umbrella.
The sky overhead is filled with dancing curtains of color. Charged particles from the nearby star make auroras far more extreme than the northern lights on Earth. There is something even more unique about this newly discovered world. Bellerophon orbits its sun in a blistering 4.2 days.
No self-respecting planet goes around a star in 4.2 days. None of the planets in our solar system take such a short amount of time.
For scientists, the tiny orbit challenges long-held notions of how planets form.
The fact that the planet was orbiting every 4 days was a total puzzle until one night in the middle of the night I woke up and said, well, this must be proof that planets migrate inwards. They don't stay put where they are.
The key to the puzzle is found in how planets are made.
Planets are a byproduct of star formation. When stars form, they have a disk of dust and debris around them, and out of that debris, planets form.
Much of what we know comes from Hubble Space Telescope, as it aims at regions like the Eagle Nebula. This interstellar cloud is studded with collapsing disks of dust and gas. A giant clump grows in the center of each disk. Temperatures reach a searing 18 million degrees. The same nuclear fusion that powers our sun is unleashed. The star is born. Radiation from the star generates a stellar wind that sweeps away leftover dust and debris. Some of the dust survives, and remains in orbit around the newborn star. Over millions of years, the dust sticks together, forming knots that grow into asteroids, and the asteroids grow into planets. These planets migrate through the disk until they find a stable orbit. This is why Bellerophon is so close to its parent star. But one newly discovered world has found its stable orbit in a place no planet should ever go. 2001. Hubble Space Telescope is directed to an obscure star, some 150 light-years away from Earth, in the constellation of Pegasus. This is the same region where Bellerophon was found 6 years earlier. Hubble is tracking another hot Jupiter, discovered by astronomer Geoff Marcy. But this one is different from Bellerophon.
You've probably heard of the planet HD 209458b. It's a terrible name.
A terrible name for a terrible place. HD 209458b has been dubbed by some as Osiris, after the Egyptian god of the dead. Osiris is over 200 times more massive than Earth. It has migrated perilously close to its sun, at a mere 4 million miles from the blazing solar surface. Osiris broils in a planetary hell. The average daily temperature on Osiris is over 2,000 degrees. Forget global warming. This is global frying, and it causes Osiris to lose an estimated 550,000 tons of air every second.
There's a leak of gas, a steady stream of hydrogen and helium, and that's making a big, huge cloud all around the planet.
Its atmosphere is bleeding into space. Scientists speculate that a colossal trail of gas spirals behind the planet for thousands of miles. Osiris presents an unprecedented opportunity for astronomers. Using Hubble, they analyze the alien planet's bloated atmosphere.
This is the absolutely first time where we could tell what is the composition of the atmosphere of an extrasolar planet.
Surprisingly, Hubble detects many of the basic chemicals needed for life. Sodium, carbon, hydrogen, and oxygen. But Osiris is far too hot for life as we know it.
There may be other forms of life, however, that thrive on higher temperatures.
But there's no solid surface as we know it on a hot Jupiter. So this life would have to be just tiny little microbes floating around on aerosols. And on our own Earth, we have life that floats around in our atmosphere. But that life didn't start there. So life almost certainly would not exist on hot Jupiters.
Astronomers have discovered many hot Jupiters since Bellerophon was found in 1995. But conditions on these worlds rule them out as places where the drama of life can unfold. One of these gas giants is a planet that teases the rules of evolution. Astronomer Geoff Marcy discovers something shocking about a planet orbiting a star called 16 Cygnus b, located some 70 light-years away in the constellation of Cygnus, the Swan.
The planet was clearly in an elongated orbit, bringing the planet close to and then far from the host star. And this, of course, defied our expectations based on our own solar system, where all of the planets go around our sun in nearly circular orbits like phonograph grooves in a record.
Like a giant yo-yo in space, the gas giant swings back and forth across its solar system. That is like the Earth swooping 25 million miles closer to the Sun, then slinging past Mars, all the way out towards Jupiter every year. And like all of the gas giants in our solar system, this yo-yo planet might have an entourage of moons. Marcy speculates that one of these moons could be similar to Earth.
And here's where the interesting story begins. Imagine a rocky moon with lakes, oceans, maybe streams and waterfalls on the surface. The moon orbiting its planet, the two of them orbiting the host star.
Unlike the airless moon that circles the Earth, this moon is a world with extreme seasons. On Earth, the seasons are caused by the tilt of our planet. Here, they are caused by the elongated orbit.
These poor planets that are in these elongated elliptical orbits suffer terrible changes in their climate throughout a year.
As they make their closest approach, the yo-yo planet and its moon are blowtorched by the star. Summer begins. The atmosphere on the Earth-like moon is savaged with raging storms. Category 5 hurricanes on Earth are tiny eddies compared to the monster vortexes that form here. The clouds thicken as the water evaporates.
Temperatures rise dramatically. Any water or gases would heat up, and indeed the oceans would boil into steam, so you'd end up with a big steam bath.
During the peak of the summer, the entire moon is smothered in 800-degree temperatures. This is the closest approach to the star. During its 26-month orbit, the summer season is barely 2 months long. But what a season! The planet and its moon swing away from the furnace of the star. Temperatures fall to ranges we would find temperate and comfortable. With the coming of fall, the rains return to the parched and roasted moon. Dry ocean basins are replenished, and the seas rise to form new shorelines. Tranquility prevails as the yo-yo planet and its moon slip into the deep freeze of winter. Now, over 200 million miles from the star, the daytime sky is dark. Temperatures hover around 260 degrees below. Winters are long, lasting 17 months. With the coming of spring, the sun looms large in the skies over this hapless moon as the ice cracks and melts violently. Huge icebergs calve into a stormy and fast-rising ocean. For 2 preciously short periods, during the spring thaw and the autumn rains, the climate on this Earth-like moon is balmy and comfortable. At a distance of 93 million miles from the star, roughly the same distance as Earth from the Sun, the elliptical orbit of this planet and its moon crosses an area around the star some scientists call the Goldilocks zone. The conditions here are just right for life.
If you're too close to the star, then it's too hot. If you're too far away, then it's going to be too cold and everything's going to be icy. But then if you're right in the middle, it's just right.
Every star has a Goldilocks zone. Where that zone is depends on the size and temperature of the star. In our solar system, Venus marks the inner boundary and Mars the outer boundary. Earth and its abundance of life is right in the middle. The Yo-Yo planet passes through the Goldilocks zone twice a year. For 3.5 months during the spring as it races inbound, and again in the fall for 3.5 months as it hurtles back into the colder reaches of space. Could life survive the conditions outside the Goldilocks zone?
There could be life forms that are smart enough to hibernate, as do animals on the Earth during the winter season. If this sounds fantastic, I offer you the tidal zones on the Earth. On the tidal zones, life proliferates, of course, near the seashore, and they do so despite tides. The water coming in, covering many of the life forms, the water going out at low tide, and yet those species survive perfectly well.
The strange cycle of the Yo-Yo planet's orbit creates fleeting conditions suitable for life, but also for death. Some alien planets are even more bizarre. Imagine a world that has no star to orbit. Scientists speculate that our galaxy is teeming with rogue planets, adrift in the murky lanes of interstellar space. These are orphaned worlds, planets that are booted from their solar systems by the chaos of planetary migration. Astronomers call such worlds planemos.
Planemos are planets without a star. They're just drifting through the galaxy indefinitely.
What massive force would it take to kick a planet out of the solar system?
When a young star forms with a contingent of planets around it, many of those planets gravitationally interact with each other. They yank on each other, slingshot each other, so that one of them is ejected from the planetary system, voted off the island, if you will.
If you were, unfortunately, a resident on a planet that was kicked out by a collision or a near collision with another large object, you'd probably rapidly move out of the habitable zone.
There are hundreds of billions of these lost, wayward, poor, wandering planets out in our Milky Way galaxy with no parent star to warm them up.
Cold, dark, quiet. Because planemos have no sun, they are worlds without days or years. They keep vigil through an eternal night. Planemos are solitary wanderers, sentinels of the galaxy. Just because it's out there drifting in space doesn't mean a planemo is dead.
If the planemo is a rocky world, it could well have life on it.
A small rocky planemo without an atmosphere will slumber in extreme cold, far colder than the coldest winter day on our own South Pole. But a planemo large enough to retain an atmosphere traps the heat generated when the planet was first formed. It is the ultimate greenhouse effect. The heat and energy comes from the molten core deep inside the lonely planet. If the planemo is a gas giant like Jupiter, it may have a system of moons. The gravitational pull between the Planemo and its moons creates friction, causing the interior of the moons to stay warm.
These moons could also have life on them, in the same way that Jupiter's moon Io has volcanoes and has a lot of heat energy being generated by interactions with Jupiter and the other moons.
If anything lives here, it will be single cells, like common bacteria found on Earth. Not complex life forms. Without a sun to provide photosynthesis, these tiny organisms derive their energy from the chemistry in the soil of the Planemo, or its moon. On Earth, there are similar conditions. Colonies of bacteria are found deep within mine shafts in South Africa. They have no access to oxygen nor light, and survive entirely on the chemicals they make from the surrounding dirt. Their metabolisms are extremely slow, and they reproduce only once every 1,000 years. If life dwells on a sunless Planemo, it could be organisms like them, marooned when their planet was young. While Planemos slumber undisturbed, there are worse places to be in the universe. Like in the company of this lethal pulsar, some 980 light-years from Earth, in the constellation of Virgo. From afar, a pulsar looks like a blinking light, but up close, pulsars machine gun their surroundings with deadly radiation. They are no place for planets. Yet something interferes with the precision of this pulsar. One explanation is that the anomaly is caused by a planet. But many astronomers are skeptical that planets orbiting a pulsar can exist.
The reason that's a problem is because pulsars are formed in these incredible explosions.
When a red giant star explodes, a titanic fireball known as a supernova unleashes as much energy in 1 minute as our sun generates in its lifetime.
When a star goes supernova, the shockwave is so immense it's hard to imagine any planet surviving that.
When the cosmic dust clears, all that remains is the crushed core of the red giant, pulsing in the heart of an expanding debris field. Matter blasted from the colossal explosion falls back to the pulsar and forms a disk. Within this chaos, a new world arises, born of fire and destruction, a planetary zombie raised from the carcass of the former red giant star.
It's amazing that planets could form in that environment.
A planet orbiting a pulsar will give you the feeling of being in a disco bar with a very strong strobe light, which is the pulsar.
Radiation from this stellar beast breaks down the organic molecules needed for life.
The pulsar has these very strong magnetic fields that are being spun around as the star is rotating quickly, and it's picking up any material, electrons, protons, and speeding them up and slinging them out at high speed. So it's like a solar wind with a vengeance.
I can't imagine that there would be much of an opportunity for even simple life, microbial life, to emerge and to flourish on a planet around a pulsar. Largely because if you were in the pulse, you'd be severely energized, and if you were not in the pulse, you would be completely devoid of energy.
The discovery of pulsar planets shows how new worlds can form in the wake of a star's destruction. No matter where a planet arises, the process of its birth is fraught with danger. Sometimes, the violence is so great, the end of the world comes before the beginning. 2007. Astronomers using the giant Gemini North telescope make a strange discovery in the Pleiades cluster some 400 light-years from Earth. A star known only by its catalog number, HD 23514, is surrounded by a giant donut-shaped cloud of dust and gas. The star in the middle of the donut shape is about 100 million years old. A cosmic toddler in astronomical terms. Our Sun is 45 times older. The conditions are perfect for planets to form. But spectral analysis finds something strange. The dust is utterly pulverized. Typically, a newborn star is surrounded by fledgling planets.
Planets form around the young star in a protoplanetary disk of gas and dust. And then these planets go on their merry way orbiting the star, not realizing that they're in an orbit that's too close to another planet.
Millions of years ago, two primordial planets orbiting HD 23514 are spinning toward doom. As the two worlds close in, tidal forces torque each planet from spheres to egg shapes. Nothing remains. The two worlds are annihilated, creating the dust and debris seen around star HD 23514. 4 billion years ago, a similar apocalypse came to Earth. A Mars-sized planet forms in roughly the same orbit as the newborn Earth. Like the planets at HD 23514, Earth and this Mars-sized body are barreling toward each other.
If you happen to be unlucky enough to be standing on a growing planet when it was in the process of still becoming the Earth, you might wake up one morning and notice that the sky was getting darker and darker as a Mars-sized body was coming at you within a period of less than an hour.
And when it hits, the shock wave is felt all over the planet, scouring the surface of the Earth. The collision obliterates one side of the planet. Molten rock sprays out into space. The entire globe is peppered by meteors and noxious vapor.
It would actually make hell look like a Bahamas vacation.
The debris field from the collision coalesces and forms our moon. It is a new beginning for our planet.
Collisions are part of the birth process for planetary systems. Building up a terrestrial planet is probably all about colliding pieces of rock together.
And all across the galaxy, colliding pieces of rock are forming terrestrial worlds that defy the imagination.
There is a new planet out there, a planet we were not aware of existing before.
It is not just one planet. It is a new type of planet. Earth on steroids.
I like to call them super-Earths. They're just like the Earth, except bigger, up to about 10 times the mass of the Earth. One family that the super-Earths resemble just like our own Earth. Continents, oceans. Some of them may be very dry, like Mars. And then another family that we call water worlds or ocean planets that are completely covered with water.
Welcome to Gliese 581c.
This planet was found by Michel Mayor, and it orbits with 2 other planets around a very small star.
It's only 20 light-years away in the constellation of Libra and is one of the smallest terrestrial planets found beyond our solar system. That doesn't mean Gliese 581c is small. It's still a super-Earth with 5 times the mass of our home planet. But it's the possibility of liquid water that excites scientists.
An ocean planet feels like being in the middle of the Pacific Ocean, with no land in sight, just water, puffy white clouds, and blue sky above you. The winds on the ocean world are going to be similar to that of the Earth, so it will be a very good place to sail.
The weather's absolutely perfect. Every day you get a clear blue sky and the sun just stays in the same place. Now how's that for weather prediction?
No land anywhere. Even miles beneath the surface.
This water layer would extend very far down, at least a quarter of the way down in the planet.
But as we dive deeper into the sea, the pressure builds. At 35,000 feet below the surface, we pass the point where the deepest oceans on Earth bottom out. We pass the 100,000-foot mark. The pressure is so great, water itself begins to take on surprising new forms. At a depth of 10 times the greatest ocean depth on Earth, we reach the bottom.
When you have a large amount of water, then at the bottom of an ocean, you will form very high pressure in excess of 1 million atmospheres. And that pressure will compress the liquid water, that is the ocean, into a state which we call ice 7.
No, it's not like ice in your refrigerator. The molecules of water that are in the ice in your refrigerator are kind of all jumbled up. But if you form ice under very high pressure, then the water molecules can become ordered, they can become aligned.
I can show you a crystal that is a very good analog to ice 7. This is halite, also known commonly as rock salt.
Ice 7 may exist within our own solar system. Europa, a moon of Jupiter, could possibly have a mantle of liquid water surrounded by a thick, icy crust. The pressure from the crust is so great that Ice 7 might exist deep within these uncharted seas. If we scale up and thaw out Europa, it could be a water world similar to Gliese 581c.
One could imagine that life could emerge on a water world. After all, water is essential to life on Earth.
Everywhere on Earth where there is water, there is life. You cannot find a sterile drop of water on Earth unless you put it in the microwave yourself.
On this water world, there could be bacteria or any kind of life in the ocean itself.
But not all of the super-Earths are water worlds teeming with life.
When we talk about super-Earths, we talked about 2 major families, of mostly rocky with some water and mostly water with an endless ocean. But one has to add to those a 3rd family of probably very rare super-Earths and Earth-like planets, which are called carbon planets.
A carbon planet is unlike anything we've ever seen anywhere. A place with an alien chemistry, but loaded with very earthly treasures. Throughout our galaxy, there are planets barren and poor and inhospitable. But science is on the trail of a new type of planet, an entire world of treasure.
In our own solar system, in our sun and in all the stars nearby, there's always more oxygen than carbon. But if we think of a place in the universe where there's more carbon than oxygen, then planet formation is very different.
Spectral analysis shows carbon to be far more plentiful, 26,000 light-years away near the center of our galaxy. Planets that form here may contain a rich abundance of carbon. The morning sky on a carbon world would be anything but crystal clear and blue.
I'm picturing a yellow haze with black clouds of soot. And as you descended farther down in the atmosphere, I could imagine lakes that were made out of compounds like methane or gasoline. I'm picturing these bubbling, foul-smelling pits of black ooze, like an oil well.
With little or no water in the atmosphere, the air is made of carbon compounds.
Methane, butane, pentane, benzene, all these different kinds of carbon compounds that separate out when you refine gasoline. One day it might be raining benzene. The next day it might be raining butane.
Alien as carbon planets might seem, the air quality could be familiar to some.
The air in a very benzene-rich planet will resemble that of LA. A lot of small particles that unfortunately we are quite used to from the exhaust of cars.
Despite the pollution, carbon planets could come with a sparkling upside.
You might see diamond because the planet may have substantial quantities of pure carbon that it's formed out of. And pure carbon, when you compress it, tends to form into diamond.
The secrets of exotic planets like these are waiting to be discovered all across the galaxy. But astronomers won't be satisfied until they find the Holy Grail. A planet like our own, one that sustains life, the next Earth.
People always ask me, do I think we're going to find another planet like Earth? And I answer, absolutely.
Every star probably has planets roughly the same size as our Earth.
We think that essentially every star has several Earth mass or super Earth mass planets. So if you have, say, 200 billion stars in the galaxy, that may mean there are 400 billion Earths in the galaxy or more.
400 billion Earths. The Kepler Space Observatory is the first instrument capable of finding one of these planets.
Kepler is looking at the constellation Cygnus in the night sky at 100,000 stars, taking picture after picture after picture, minute after minute. And the goal of Kepler is simple: to look for stars among the 100,000 that dim.
When a star dims slightly, it means a planet passes in front, blocking some of the light. How long the star dims and how much light gets blocked will tell scientists about the size of the planet and the distance from its sun.
A good analogy for this is looking for the dip in the light that you would see from a searchlight if a small moth flew across the searchlight. And so it's a really tiny dip in the light as the planet transits.
It is a very powerful technique because it allows you to discover planets that are even smaller than the size of the Earth around stars similar to the Sun.
It is a technique that is changing the course of science.
We think we may be able to find a planet that is habitable in the next few years.
Scientists estimate the Kepler mission will find a minimum of 50 alien Earths.
One of the big questions that anybody looking for life beyond the Earth is facing today is, what if we don't recognize life even though we discover it?
Conditions on an alien Earth may cause life to evolve differently.
My hope is that we'll see some sign that will make our hairs stand up on the back of our necks.
Whatever that sign is, it will be the first chapter on the greatest scientific story ever told.
In 2004, the Cassini space probe approaches the ringed planet Saturn and its 56 moons. It discovers something almost unimaginable, conditions that might support life. And if those conditions could exist so close by, what might we find in the next galaxy? A planet just like Earth. For millennia, we humans have looked to the skies and wondered whether we're alone in the universe. Today, we're closer than ever to knowing the answer. Some scientists believe we'll get our first look at our extraterrestrial cousins in the near future.
I hope it's in the next 10 years, and I'm ready for it next week. So, the sooner the better.
What's more, we could find these aliens not on distant planets in unexplored galaxies, but right next door in our own solar system. Scientists are now honing in on proof that ET is out there and living on the most hazardous of worlds. Our safari will journey to 7 destinations in our solar system to see just where these creatures could be and what they might look like. These exotic lands are unimaginably harsh. Life as we think of it would perish in an instant. But alien life may be far tougher than we expect, as we're learning from a surprising group of living things right here on Earth. Until just a few decades ago, we were sure our planet was unique. It is the only one we've found so far that has nurtured the evolution of millions of species. Thanks to its abundant sunshine, warm water, and protective atmosphere. We logically concluded that life needed each of those things, a conclusion that ruled out all other known worlds in our solar system. But then, biologists began combing some of the Earth's darkest and coldest places. And to their surprise, they found living, breathing creatures. Biologists call these organisms extremophiles. Some don't need light or oxygen. Others survive in tremendous atmospheric pressure. It seems life can turn up practically anywhere. Take Antarctica. After years of searching this arid, frozen landscape, scientists doubted they'd find anything alive. But in 1999, a team of explorers unearthed a rock from 6 feet under the ice. What they found amazed them. When they cracked the rock open, they found it teeming with tiny creatures. Here, at temperatures of 68 degrees below zero and 6 feet under solid ice, life had found a foothold.
Biologists have been increasingly discovering life, not kangaroos, but, simpler forms of life that live at very cold temperatures, very high temperatures, very great pressures, even in places where there's sort of a high degree of radiation. It turns out life is able to live in a much wider variety of environments on our own planet than we used to think.
And if life can survive extreme conditions, not just here at home, but elsewhere in our solar system, think of what this could mean.
Unless there's something extraordinarily miraculous about our solar system or our planet, then life has got to be extremely commonplace. I mean, there's got to be large numbers of worlds with life, and some of them would have cooked up intelligent life.
In the beginning, our Earth was as deadly a planet as any. Over the first billion years of Earth's existence, cosmic debris pummeled it mercilessly. The impacts turned its surface into a broiling, seething inferno where life was impossible. But once the solar system settled down and the Earth began to cool, water appeared, setting the stage for life. In 1953, researcher Stanley Miller proved in a lab experiment just how easily life on Earth got its start. He combined water with hydrogen, methane, and ammonia, components of the Earth's early atmosphere. Then he zapped his solution with an electric charge to simulate lightning. His results shocked the world. Miller had created organic molecules called amino acids, the protein building blocks of all living things. If lightning helped jumpstart life on Earth, could it have done the same on other planets? Galactic probes have now found the ingredients in Miller's experiment throughout our solar system, including one essential to life.
One of the requirements that every form of life that we know about on Earth has, every single one, is liquid water. We've used evidence for liquid water to kind of guide our search for habitable environments.
Our safari is headed to 7 worlds, some possibly rich in water, where scientists believe aliens might be hiding. While any life there might have begun much like life on Earth, how it looks now is anyone's guess. We begin in the world that has always fired our imaginations, the planet right next door, Mars. Of all the planets where we've looked for life, it's the one we've studied most. The scientist who may get the first look at Martians, if they're found, is Steve Squires, principal investigator for NASA's Mars rovers.
Mars has always had, among all the planets, I think, a special fascination for humans. For a very long time, we've known enough about Mars to know that it is probably the most Earth-like.
It may be the most like Earth, with an atmosphere and seasons, but we humans would perish quickly on Mars. Its air is thin, 40 times thinner than the air at the top of Mount Everest. And it sits in a bad neighborhood of our solar system, near an asteroid belt. Its atmosphere is too flimsy to protect it. Asteroids continually bombard its surface. Violent winds can whip Mars's sandy soil into storms that consume the entire planet for weeks and spawn tornadoes 8 kilometers high. Midday temperatures at the equator of 1 degree Celsius fall to -70 at night. David Grinspoon is a curator of astrobiology at the Denver Museum of Nature and Science. As he sees it, Mars would be warmer if it wasn't a planetary runt.
When I grab coffee on a cold morning, I know that a small espresso is going to cool off quickly, whereas a larger coffee is going to stay warm much longer. Large objects stay warm longer because their interiors are shielded from the outside where the cooling occurs. And planets are exactly the same way. A small planet will cool off early in its history. A larger planet like Earth will stay warm for billions of years, which makes it a better place probably to look for life.
Despite Mars's drawbacks, it has always fascinated scientists because its terrain seemed to give evidence that it might support life. Its dynamic landscape of mountains, volcanoes, and deep ravines is not unlike our Earth. To early astronomers, these features look like oceans and rivers, and even a system of canals, supposedly not just supporting life, but actually produced by it.
Percival Lowell in the United States observed these things and inferred that, in fact, these things were so straight and so regular in geometry that they had to have been the product of intelligent life. Okay? Well, he was right. The problem was the life was at the wrong end of the telescope. In viewing this thing visually through a telescope eyepiece, the human eye-brain combination started to connect things that weren't really there.
Lowell was not alone. Some scientists were shocked when the probe Viking 1 beamed back this image. Is that a human face? Perhaps produced by Martians in their own likeness? Until recently, we've never really known where to look in our solar system for extraterrestrial life. But we've always known what the aliens would be like once we found them.
Consciousness. I was on a table.
Usually, there is more than a hint of the Earthling in our aliens. Hostile or lovable, they tend to resemble mutant images of ourselves. As a senior astronomer at the Search for Extraterrestrial Intelligence Institute in California, Seth Shostak has spent his career listening for the radio waves of a distant alien society.
There's no reason to assume that they're going to look like us or even think like us or behave like us or have language. You know, you just have to look at the variety of life on Earth and you see that, you know, nature can come up with lots of different forms.
But if there is life on Mars, how could it survive in such extreme conditions? Since the 1960s, scientists have sent dozens of probes to the Red Planet. The first pictures of the barren landscape quickly dashed any hope of finding intelligent beings. But what scientists did see startled them. Though there's no evidence of Martian-made canals, there are signs that Mars actually may have had water. Some think the angry red planet might once have been blue.
You just have to look back a couple of billion years, 3.5 billion, 4 billion years ago. Mars had a thicker atmosphere, had water on its surface clearly. Maybe it developed life. And as it slowly went bad, you know, the life had to adapt.
Life may have adapted, not died off, because some liquid water may still exist underground. But with no surface water, frigid temperatures, and ultra-thin atmosphere, Mars is a planet only one kind of creature could love: an extremophile. Extremophiles thrive in the cruelest of places. To see where they might lurk on Mars, we head to the Valles Marineris, a massive rift in Mars's surface, 20 times wider than the Grand Canyon in places, and almost as deep as Mount Everest is tall. Lakes may have once flooded this valley, and those lakes could have hosted life. As the water dried up, life could have evolved to cope with the harsher environment. We won't know what these extremophiles are like until we find them. But they may resemble creatures that exist in extreme places right here on Earth. An unusual team of biologists, called astrobiologists, study Earth for the kinds of life we may find in outer space. Astrobiologist Rocco Mancinelli is on the hunt for Mars's extremophiles.
If it went beneath the surface, and some of it undoubtedly did, then what happened to it? Well, it formed brine pockets. So what kind of organism can live in a salty brine? A salt-loving organism.
Astrobiologist Chris McKay thinks he knows the kind of salt-loving creatures that might survive on Mars. Creatures much like those he's found in one of the driest, saltiest places on Earth.
The fundamental challenge to life on Mars is, in a sense, the fundamental challenge of life here in Death Valley. It's dryness. That is the hardest thing for life to adapt to.
Thousands of years ago, a salty lake covered Death Valley, just as lakes filled Mars's Mariner Trench.
Move in closer. This is still wet, a little wet.
This appears like a lifeless place, a big, flat, white, empty horizon. But yet, just below the surface, we find layers of algae and bacteria growing. They're living in an environment that in many ways is fundamentally different from the environment that we sense on the surface. Here you're in a place which looks lifeless, looks dead, and yet you dig down and hidden underneath, there it is.
Beneath the salt is a layer of hardy green algae that survive on the water and light that trickle through. The algae in turn feed salt-loving microorganisms.
Here in deserts on Earth, dried, salty lake beds, we're going to find them on Mars as well.
Salty deserts are not the only places life might be hiding on the red planet. There are Mars's tremendous volcanoes, some of them 6 times larger than those on Earth. Astrobiologist Penny Boston studies the caves, called lava tubes, left over after volcanic lava has dissipated. Not long ago, we assumed caves like these were devoid of life. They get no sunlight, and no sunlight means no photosynthesis. But in lava tubes outside Albuquerque, New Mexico, Boston has found evidence of extreme life.
Because we know Mars has many, many lava tubes. And so here we have the opportunity to see how these formed and also to look at the life that inhabits them.
The extremophiles Boston has found appear to be thriving. They get their energy by feeding on the minerals in the cave wall.
So here we're up close to the wall, and you can see these white patches here growing against the black basalt. And each one of these is like a major city for these little guys. And they're all nestled in these little pockets in the basalt. And so these guys are permanently adapted to these freezing temperatures. They never see any light, and they get what they can find in the environment.
Are there creatures like these in the caves below Mars's volcano fields? Boston thinks so.
We are going to find life, and I just hope that I live a long and healthy life so that I can still be around to see that.
We may already have had our first glimpse of Martians, not from our visit to their planet, but from their visit to ours. 16 million years ago, an asteroid slammed into Mars and propelled a 2-kilogram rock into space. Amazingly, that rock sailed to Earth and came to rest in Antarctica. Inside, NASA scientist David McKay and Everett Gibson were amazed to spot the outlines of fossils. Water has carved small tunnels in the rock. And in these tunnels, McKay and Gibson found what they believed to be evidence of bacterial life.
These are little microbes, and they're dead, and they're fossils, or in some cases, we don't even see the forms. We see the footprints or the evidence that they were there.
Life from Mars? Maybe. The hunt is only just beginning. NASA plans to send a rover called Phoenix to Mars. It will study the planet's ice cap and probe 3 feet beneath the surface. NASA even has a plan to send human visitors. They may not meet the little green men of our imaginations, but they could encounter life in some form. What will it look like? It is likely to be a subterranean dweller with an ability to survive on little water. Perhaps an organism with a taste for minerals, like the creatures in the lava tubes of New Mexico. Even the smallest find would have enormous implications. Proof that life is not unique to Earth, but exists just next door. Our safari to the places in our solar system likely to harbor alien life now takes us past the asteroid belt on the far side of Mars. Here, Jupiter reigns. But this planet, the largest in our solar system, is fairly hostile to life, thanks to its toxic gases and overpowering gravity.
Not only is it pretty cold out at Jupiter, it's also, it's got this really thick atmosphere, tens of thousands of miles thick, and it's got ammonia and methane and, things used to clean the bathroom. But Jupiter has more than 60 moons that we know about.
At first glance, those moons would seem unlikely places to seek alien life. Their atmospheres are thin, and they are inhumanly cold. The temperature on Callisto is lower than -200 degrees Celsius. The scientific probes Voyager and Galileo have detected little on the surface of these moons but ice, with one dramatic exception. Io is one of the closest moons to Jupiter. When NASA sent Voyager 1 to Io in 1979, astronomers were astonished to find its surface roiling with giant volcanoes.
Io is the most volcanically active place in the solar system, just spewing volcanic material from its surface all the time.
What could be heating the interior of this frigid moon? Amazingly, it's the force of gravity from Jupiter. The giant planet exerts enormous gravitational pull on its moons. The closer the moon, the stronger the force. So strong, it can actually stretch their crusts. But some of these moons have elliptical orbits, so as they near Jupiter, the crust stretches towards it. When they move further away, the crust relaxes back towards spherical. This constant tidal movement creates friction deep inside, and that friction generates heat. It's like rubbing 2 sticks together to start a fire. The pull of Jupiter is heating Io from the inside out. Volcanic fumes and lack of water make Io inhospitable to life. But Jupiter's other large moons are more distant, close enough for Jupiter's gravity to warm them from within, but distant enough to remain calm on the surface. 3 of them look particularly promising as possible homes for alien life. The one furthest from the giant planet, Callisto. On its surface, Callisto looks like our moon, scarred and cratered by countless hits from asteroids. Those impacts may have melted the surface ice for brief periods, allowing life to take hold. But in 1998, the Galileo spacecraft detected a much more promising incubator deep beneath Callisto's surface. Radioactive rocks and tremendous pressure in its core generate heat inside Callisto. The heat may be melting its icy crust from below, creating a hidden ocean. and hidden oceans could mean hidden life. As we fly closer to Jupiter, we find its largest moon, Ganymede. Ganymede is also deeply scarred. Ridges rise above its surface. Those bright spots are craters as big as 5 kilometers across and likely to be lined with frost. But these photos offer the most compelling clues to where life here might hide. They show flowing glaciers, glaciers that resemble those on Earth. Ganymede's moving glaciers could also be signs of heat within. So, like Callisto, Ganymede could also have a hidden ocean, buried beneath as much as 190 kilometers of ice. The third moon on this leg of our alien safari is the most intriguing. It is called Europa, and of the three, it resides closest to Jupiter. That proximity to the giant planet means Europa's core may be very hot, far hotter than Callisto's or Ganymede's. But its surface remains frigid, a potent combination for life, since there could be a temperate zone where they meet. Mammoth fissures scar Europa's thick crust of ice, a sign that ice is always shifting. On our own planet, we see the same cracks in the ice sheets covering the Arctic Ocean. Europa's crust may be riding the largest ocean in the solar system, an ocean twice as large as all of Earth's put together.
Now, those oceans, if they're there, and the chances are pretty good that at least some of them are, they've been sitting around for a long time, 4 billion years, a little longer, right? In 4 billion years, an ocean of water, do you think anything might have cooked up there? Well, it certainly seems plausible.
The environment in Europa's ocean is more or less as nice as the environment in our own ocean, as a place for living things to exist. Heck, things from planet Earth could probably live in the European ocean.
But Europa's oceans would be very cold, even slushy. And sunlight never penetrates them, thanks to an icy cover that may be 16 kilometers thick. We might never have thought life could exist here if not for a revolutionary discovery off the coast of Ecuador. Deep in the Pacific, biologists have found flourishing communities of tube worms, crabs, and even squid. These creatures are thriving despite complete darkness, extreme cold, and the pressure of the deep ocean. They feed on bacteria that take their energy not from the sun, but from chemicals erupting from the sea floor. We might find very similar volcanic vents on Europa, supporting their own web of life. To find out, NASA scientists would like to put a lander on the European surface. Some would like to send a cryobot, a robot that would melt the ice and release a probe into the liquid below.
That's not so hard to do. You just have to melt your way through. But you're going to have to melt your way through not a couple hundred feet, but maybe a dozen miles of ice. And send down a fishing line with maybe a video camera and a light bulb on it and look around.
In all that water, we can't rule out the possibility that very simple life forms have evolved further. We might even find creatures as advanced as some here at home. Most likely, however, we would find microbes. But even that would be a sea change in how we view the birth and growth of life. Europa was warm. What if the place is one of the coldest known? Or if its lakes flow with toxic chemicals instead of water? These are the worlds we find as our safari continues even deeper into space. As our safari in search of alien life sweeps by the ringed planet, Saturn, we can see the violently swirling gases that choke its atmosphere. We can also feel Saturn's gravity, weaker than Jupiter's, but still formidable. We'll keep moving. We're not likely to find living things here. Saturn's rings are also extremely inhospitable. They're made of rock and ice, as small as a grain of sugar or as big as a house. But Saturn has many moons, 56 that we've spotted so far. Our safari heads first to one of those moons, a tiny frigid satellite called Enceladus, just 500 kilometers in diameter. Here, gravity is very weak, a fraction of that on Earth. And Enceladus has hardly any atmosphere. It reflects back into space almost all the sunlight that hits it, making it the shiniest object in our solar system. Until very recently, we also thought Enceladus was too cold to support life. It appears we were wrong. In 2005, after a 7-year journey, the Cassini spacecraft approached the tiny moon and detected something that stunned the mission's principal investigator, Caroline Porco.
So this was the picture that just, grabbed us. Just was shocking.
Those are plumes made of water from a geyser. The geyser's steam and hot water hit the cold vacuum of space and explode into a jet of ice. With little gravity to rein it in, the ice cloud can grow as big as Enceladus itself. Porco has never seen anything like it anywhere else.
It's like a planetary explorer's dream to come upon a body like Enceladus. Those jets, those fountains, if you will, just spewing vapor and icy snow hundreds of kilometers above the south pole of Enceladus.
There's only one conclusion. Tiny, frigid Enceladus is piping hot within. Like Jupiter, Saturn's giant gravitational field tugs on its satellites, creating friction and heat within.
As far as we can tell now, it seems like an inescapable conclusion that there may be liquid water deeper down on Enceladus because it's warm. And the best models we can put forth right now to even explain the warmth, much less the jets, seem to indicate that you would get temperatures warm enough to melt water.
Heat, liquid water, even the furthest reaches of our solar system may contain the chemistry for life. What kind of creature could live in the steamy waters of a geyser? Thanks to hot springs back on Earth, we have some idea. At one point, we assumed nothing lived in the steam-driven fountains of Yellowstone National Park. But then, biologists discovered microbes in these waters. Microbes that feed on chemicals dissolved in the water. Today, we call them thermophiles. The hardiest can thrive in boiling water. Could there be thermophiles on Enceladus? To find out, our safari takes us in for a close-up of this extraterrestrial Old Faithful. It's too cold for anything to live near the surface, but temperatures there are minus 165 degrees Celsius. But what about the hot water inside? In the ice plume above Enceladus, Cassini's probes have found carbon dioxide and methane, chemicals that could feed life below. Just as the chemical-laden springs of Yellowstone feed microbes living there.
We have a body that very, very likely has liquid water in its interior, has shown us already it's got simple organic compounds and, a whole host of things that make it, I think, a major body of astrobiological interest in our solar system.
If Enceladus has been a shock, astronomers have been astounded by another of Saturn's moons, Titan. It may be the unlikeliest to harbor life. Titan gets only a limited amount of sunlight, about 1,000th as much as Earth. Probes sent to Titan have detected ice, but no liquid water. And at temperatures of minus 138 degrees Celsius, that ice is hard as stone. What could possibly make Titan a promising environment for alien life? Remarkably, Titan in many ways resembles the Earth, but not the one we know now.
Titan has turned out to be the body fantastic in the Saturn system, which is long suspected of having an environment at the surface, not only similar to the kind of environment we find here on Earth, even, believe it or not, similar to the kind of environment we had on Earth before the emergence of life.
Titan intrigued Caroline and Porco's team so much, they directed the Cassini spacecraft to send a probe there in 2005. It was the most distant surface mission ever conducted. The probe saw just ridges and plains. But a later flyover by Cassini spotted a shoreline. Soon, thousands of lakes came into view, at least one bigger than the Great Lakes of North America. It's the first time we've ever detected liquid on the surface of another celestial body.
Kind of looks like Minnesota, except the lakes are not water. They're liquid natural gas. But liquid natural gas is a liquid.
And that's not snow. Those are methane flakes. Like Earth, Titan has weather. But it's of a rather psychedelic kind. There are even methane hurricanes.
It's not water, it's methane, doing all the exact same things. Raining, evaporating, flowing in rivers. So you have something that is basically doing what water does on Earth. On Titan, only it's methane.
A similar scene may have existed on Earth 4 billion years ago, making scientists suspect that Titan could also be an incubator for life.
Chemistry does go on. At those cold temperatures, it's really slow. But Titan has had 4 billion years in which to do some chemistry, and maybe in that period of time, maybe something is cooked up.
It would have to cook up without liquid water, something we've never seen before. But scientists aren't ruling it out. The substitute could be the methane, so abundant on Titan. Used for fuel on Earth, methane was long thought poisonous to all life. But in 1997, researchers examined mounds of methane ice in the Gulf of Mexico, and they were astonished to find colonies of small centipede-like worms thriving amid the frozen substance. They think the worms may eat bacteria that feed on the methane.
In general, things that we think of as deadly, many of them are potentially lively if you can figure out an evolutionary way to tap into that energy rather than having it destroy you. Then it can be bountiful.
There could be one more complication for life on the surface of Titan. With only a weak magnetic field to shield it, living things on the surface could be exposed to cosmic radiation. But that might not be a problem for an extremophile, as we found here on Earth. Biologists have uncovered plenty of life near Chernobyl's contaminated nuclear reactor. And even swimming in toxic radioactive spills, actually feeding off the decaying molecules. It's possible Titan's life forms could do the same. To find life on Titan, we may have to dive into its methane lakes, where we might find chemical-loving bacteria. We may even find microbes resistant to radiation, not unlike those here on Earth at Chernobyl, living on its rock-hard ice sheets. Organisms that eat methane might give off heat, melting the ice, possibly creating another fountain for life. There's no doubt, life on Titan would be a strange brew. But we have yet to visit the most bizarre world where scientists believe life could exist. And it's much closer to home. Our safari of the world's most likely to harbor alien life has taken us far. We've visited frigid deserts, submerged oceans, and methane lakes. But the world we are about to visit may be the most extreme of all. For our final stop, we are turning back toward Earth, to Venus, our closest planetary neighbor in the solar system. If life can survive here, it seems it could exist almost everywhere. To reach the surface of Venus, we have to fly through a dense layer of yellow clouds, 64 kilometers deep, with a composition similar to battery acid. The atmosphere here is 90 times heavier than Earth's, too heavy for a human to tolerate. On the ground, there are extinct volcanoes and lava flows as far as the eye can see. They cover 85% of the planet's surface. It is hard to believe Venus once had vast oceans.
You basically had a runaway greenhouse effect where as it starts to get warmer, the oceans start to evaporate, and then that puts water vapor in the air. Well, water vapor is a potent greenhouse gas, so that's what leads to the runaway. The oceans basically boil off, and then the CO2 all ends up in the atmosphere, and so today you have this very hot, hyper greenhouse planet.
With temperatures around 460 degrees Celsius, Venus is even hotter than Mercury, the planet closest to the Sun. Not a surface hospitable to life.
Life as we know it cannot exist on the surface of Venus because organic molecules would just be ripped to shreds by the hot gases.
But we've stopped here, not because of what's on the ground, but what's in the air. In 1982, the Soviet spacecraft Venera 14 visited Venus. In the clouds, 50 kilometers up, it detected temperatures much cooler than on the surface. What's more, it found the molecules so critical for life, H2O. So far, every bit of water we've found beyond Earth is frozen solid. Only in the clouds above Venus have we found it in vapor form, a possible incubator for life. But Venus's clouds are also filled with highly acidic sulfur. Once, we thought nothing could live in sulfur. But scientists have analyzed some of the most acidic water on Earth, leaching from a California mine.
Watch your head.
In sulfuric acid strong enough to erode metal, eat through clothing, and dissolve human flesh, they found life. Acid-loving extremophiles. These organisms feed on sulfur compounds, like iron sulfide, eating the iron and emitting the highly acidic sulfur. Do extremophiles like these float above Venus? Astrobiologist David Grinspoon likes to think it's possible.
Maybe in the clouds of Venus there are some sulfur-based organisms. Sulfur actually absorbs ultraviolet light in interesting ways, and I'm just imagining that there's maybe some kind of photochemical reaction going on where ultraviolet light is actually being used to convert chemicals into some higher energy state, which then is basically being eaten.
What will these aliens be like if we do find them? They would have to tolerate high temperatures and enormous atmospheric pressure. They would also need to thrive in acid concentrations deadly to most life forms. Perhaps they might resemble a hardier version of the acid-resistant extremophiles in California's mine.
We keep finding that life lives in places that we used to think were inhospitable. So whenever we say, oh, it's impossible, you couldn't have life in the clouds of Venus, I think we have to be very careful because they might just reflect our own ignorance or our limitations on our own imagination, and maybe not real limitations on the ultimate creativity of nature, which seems to find solutions to these problems.
As our safari returns to the cool, blue, lush and lively world of Earth, we can see why we so revere its life-sustaining gifts. But As we are learning, even the most extreme environments can harbour living things. Extremophiles may resemble the first version of life in our universe, and they could even be the most common. Could they have evolved further from these humble beginnings? Could intelligent life be out there as well? For more than 40 years, scientists at the Search for Extraterrestrial Intelligence Institute in California have been searching the skies for answers to that question. Astronomer Seth Shostak believes he'll know the sound of alien life when he hears it.
We have a couple of observing projects to try and find signals. The biggest one are our radio searches, and that's where we use big arrays of antennas, and we point these antennas at nearby star systems that we think, well, this is the kind of star that might have a planet that might be something like Earth. We point in those directions, hoping to pick up a signal that would tell us that somebody there is clever enough to build a radio transmitter.
It's a safari that never leaves home. Astronomers have also recently captured enough light from planets in distant solar systems to deduce their chemical makeup. They have found elements that may help form RNA, one of the building blocks of life here on Earth. And 20 light years away, in the constellation Libra, a team of European astronomers has found a planet that could be warm enough to have liquid water on its surface, just like Earth. Meanwhile, headed to the furthest reaches of our galaxy are 4 spacecraft launched in the 1970s. Aboard 2 of them is a map of our solar system and the image of a man and a woman. 2 others carry a sample of uranium, whose rate of decay would date the probe, regardless of language. The 2 are also carrying what could be the most universal message of all, a recording that includes a composition by Bach. Just don't expect news anytime soon. These intergalactic postcards from the Earth will take 80,000 years to reach the nearest star. Our search for life beyond Earth has only just begun. There are billions of planets yet to be explored. Every one of them holds the tantalizing possibility of life. Even intelligent life.
Just in the face of this enormity, the idea that we're the only game in town, it just doesn't seem reasonable.
I think the question of whether we're alone is profoundly important for human beings in general. If you're aware, you really have to ask that question.
Somewhere in a galaxy known or unknown, something or someone could be looking out into space, peering at the Milky Way and wondering, is there life out there?
Humankind for centuries. They acquired their name after Ferdinand Magellan's expedition circumnavigated the globe in the 16th century, and his crew used these cloud-like objects as aids to navigation. During the Age of Discovery, sailors relied on celestial bodies to reckon their own locations. The 2 heavenly clouds that attracted the attention of Magellan and his crew have fascinated people ever since. Recently, thanks to observations in the southern hemisphere using the most advanced telescopes, research on the Magellanic Clouds has taken a giant leap forward. The Magellanic Clouds turn out to be astonishing records of the very birth of the universe.
They provide a unique opportunity for studying what happens close to us in the universe And that actually tells us a lot of things about how the universe formed and how galaxies form.
Astronomers throughout the world are eager to shed light on the Magellanic Clouds, hoping to reveal secrets about the earliest days of the universe. This program follows these stars on a journey of amazement and discovery. What is the true character of the Magellanic Clouds? This has been a huge mystery since the Age of Discovery. By the 17th century, 100 years after Magellan's expedition circumnavigated the globe, Europe was producing numerous star charts of the southern hemisphere. The constellations were pictured as various creatures: a flying fish, a chameleon, a resplendent peacock, a big-billed toucan. The constellations all had exotic names. And then there was Nubecula Major, Latin for large cloud, meaning the large Magellanic Cloud. That was paired with Nubecula Minor, or small cloud, the small Magellanic Cloud. Since they moved together with the stars, they were clearly no earthly clouds. They were heavenly bodies. But exactly what they were remained a mystery. The first detailed research into the Magellanic Clouds began in the 1830s. To conduct research into stars of the southern hemisphere, England had established a royal observatory at the Cape of Good Hope in southernmost Africa. Astronomer John Herschel worked there for over 4 years. He pioneered the study of celestial objects in the southern hemisphere. In 1847, Herschel published his findings in a 450-page report. This is the catalog of objects Herschel found in the Magellanic Clouds. Some 1,000 items are listed. There are numerous records of nebulae and star clusters, similar to those visible within the Milky Way galaxy. Herschel clearly thought of the Magellanic Clouds as constituting a galaxy. At the time, most astronomers thought that all celestial bodies lay within the disk of our own Milky Way. Herschel thought that these rather indistinct and nebulous objects must be extragalactic celestial bodies. To prove that, however, one would have to calculate the distance to the Magellanic Clouds. Alas, Herschel did not possess the means to do that. Are the Magellanic Clouds inside the Milky Way or outside? An epoch-making discovery at Harvard University finally solved the riddle. The crucial evidence was supplied by photographic plates stored here. This is the world's largest archive of astronomical photographs.
As you can see, we have cabinet after cabinet, many plates, 525,000 plates in this collection. That's 25% of the world's total of astronomical photographs just in this collection. And what is remarkable about that is that it covers more than 100 years of time, from 1885 to 1989. And we began photographing the southern skies early in the 1880s, so that the Magellanic Clouds are covered from that early time.
These photographic glass plates recorded light from the stars over long periods of exposure. They enabled astronomers to capture not only what Herschel could see directly, but even far dimmer stars in the nebulae. Around the turn of the 20th century, the data etched on these glass plates were processed by a team of female analysts. The position and brightness of every single star were meticulously recorded. The analysts were actively seeking variable stars, a popular quarry at the time. Variable stars are stars whose brightness fluctuates. Of particular interest were those whose brightness fluctuated in regular periods.
This was one of the very old ones.
This type of star could help prove whether the Magellanic Clouds lay inside or outside the Milky Way.
With the,
Wow, it's a 240-minute exposure.
Here we have a glass plate of the small Magellanic Cloud, a long exposure which is taken. Some of the stars will be variable stars, but you get them at only one moment on this plate. So this is a negative plate, and we also can then make from one of these plates a positive plate. And this one can then be used as a master. When you put them on top of each other,
Superimposing an image of a given area on top of another taken at a different time reveals any change. If the star's brightness is constant, it should be a perfect match. What happens when the brightness changes? Since brightness is translated optically as size, any variability is immediately apparent. This comparative method, done plate by plate, is a way of detecting which stars are variable. One of Harvard's female star analysts was Henrietta Leavitt, an astronomer later recognized for her analyses of variable stars. This is one of the photographic plates of the Magellanic Clouds that Leavitt analyzed. Out of 100,000 stars recorded on a single plate, she endeavored to identify the variable ones. Harvard still has her handwritten logbook. She assigned numbers to each variable star, comparing readings at fixed intervals and determining the periodicity of its variations in brightness. To prevent any mistaken attributions among the countless stars in the sky, she drew detailed star charts. After 4 years of research, Leavitt published her study of 1,777 variable stars in the Magellanic Clouds. In the course of compiling these data, she made a vital discovery. She noticed that variable stars in the Magellanic Clouds with the same period had the same brightness, or luminosity. Compared with variable stars of the same periodicity within the Milky Way, the ones in the Magellanic Clouds appeared fainter. The fainter the star, the farther away it must be. In the late 1920s, after Leavitt had passed away, detailed analyses revealed that the Magellanic Clouds lie far outside the Milky Way. Precise observations determined that the Magellanic Clouds are 200,000 light-years away. That's twice the diameter of the entire Milky Way. The Magellanic Clouds were definitely other galaxies lying outside the Milky Way. A large telescope subsequently revealed a deep relationship between the Milky Way and the Magellanic Clouds. This is the 2.5-meter Hooker telescope at Mount Wilson. This telescope enabled measurement of the distances to many galaxies outside our own. It revealed features of the Magellanic Clouds that differentiated them definitively from other galaxies. This is the galactic distribution, as currently understood. The two Magellanic Clouds lie approximately 200,000 light-years away from our own Milky Way. The larger one is approximately 1/10 the size of our galaxy. The nearest spiral galaxy to our own Milky Way is the Andromeda Galaxy, some 2.3 million light-years away. That's 10 times farther away than the Magellanic Clouds. So the Magellanic Clouds are two small galaxies very near our own. Edwin Hubble, the leading astronomer of his day, described the Magellanic System thus. The cloud is an independent stellar system and a close neighbor, actually a satellite, of the galactic system. A satellite is a space object that is gravitationally attracted to another and orbits it, as the Moon does the Earth. Hubble thought that the Magellanic Clouds similarly orbit the Milky Way galaxy. This concept of a satellite galaxy eventually became the standard view among astronomers. A major discovery was made in the southern hemisphere, in Australia. The two Magellanic Clouds together make up a single gigantic space object. The discoverer was an Australian astronomer named Don Mathewson.
If this object I discovered was actually visible, everyone would be astounded. It's an enormous arc of gas stretching right across the sky. In fact, it's more outstanding than the Milky Way galaxy.
Mathewson's starting point was a research paper written by astronomers at Bell Laboratories in the United States. Their measurements of intergalactic radio waves revealed filaments of gas in the skies over the northern hemisphere.
It was a rainy Sunday afternoon, and it was quite late, and I was just turning the pages of an astrophysical journal. I plotted their filament of gas, this sausage of gas, and I thought, well, let's extend that sausage a little bit, let's blow it up a little bit. So I drew a line on this polar graph paper, and I thought, gee, it passes through the large and small Magellanic Cloud.
The line Mathewson extended into the southern hemisphere from the mystery gas mentioned in the article went right between the Magellanic Clouds. And Australia had a radio telescope well suited to confirming the presence or absence of gases. It was the Parkes Observatory. Mathewson couldn't contain his excitement. He telephoned the observatory right away. The very next morning, Mathewson jumped into his car and drove to the observatory. The director had told him that the telescope would be offline for maintenance that day, so Mathewson thought that at night there might be a chance for some brief observations. It took him 4 hours to drive to the Parkes Observatory. At the time, this giant 64-meter diameter parabolic antenna made Parkes the largest radio telescope in the southern hemisphere. When Mathewson arrived, he asked the maintenance workers if he might borrow some time on the telescope.
So all the memories come flooding back, because it was the most emotionally charged episode in my life, really. The discovery of the Magellanic Stream.
Past 10 p.m. It was only after the maintenance staff had left for a late supper that Mathewson was able to use the telescope.
Had it all plotted out, what I thought would happen. But of course in science things never happen the way you want it to. Nature is a very is a teaser. It teases you and then all of a sudden drops you flat on your face. But tonight was completely different. For the rest of the 3 or 4 hours that it took, every position that I looked at with the telescope came out to be the right velocity and the right intensity.
When the telescope was pointed along the extrapolated path of the gas stream first noticed in the northern hemisphere, further traces of gas were found along the way. The gas trail seemed to be headed for the Magellanic Clouds. That's how Mathewson was the first in the world to actually establish a link between the gas trail and the Magellanic Clouds. Subsequent detailed observations confirmed that their distributions were aligned. This intergalactic belt of gas was named the Magellanic Stream. The Magellanic Stream is an extension of the same nebulae spotted by Ferdinand Magellan. It's a huge belt of gas, stretched out as if to curve around the Milky Way galaxy. It's 1 million light-years in length. That's 10 times the diameter of the Milky Way. Like the contrail of a jet plane, the Magellanic Stream is proof that the Magellanic Clouds have passed that way. The gas is distributed as if it were encircling the Milky Way. So astronomers believe that the Magellanic Clouds are spewing out gas as they orbit our galaxy. The Magellanic Clouds, galaxies with a gas trail longer than the diameter of our own galaxy. To people of the Northern Hemisphere, the night sky of the Southern Hemisphere presents a strange spectacle. There's the constellation Orion. But it's upside down. And the Milky Way looks huge. The exceptionally bright area is our galaxy's nucleus. In the Southern Hemisphere, the mysteries of the universe seem all the closer. This is Santiago, the capital of Chile. It's surrounded by 5,000-meter-high mountains. Still bearing traces of its Spanish colonial past, Santiago is today at the forefront of astronomical research. On the way to a greengrocer's in a new part of town.
Hola. Gracias.
The shopper is Valentin Ivanov, an astronomer who was born in Bulgaria. Recently, he has been analyzing observations of the Magellanic Clouds made with one of the world's most advanced telescopes. He is affiliated with the European Southern Observatory, known as ESO. ESO has established 3 observatories in Chile from which to survey the stars of the southern hemisphere. With his telescopic observations, Ivanov has been creating the most detailed picture yet of the Magellanic Clouds.
VISTA is one of the newest projects of ESO, and it aims at creating large uniform maps of the sky. These are called surveys. One of the most important surveys that this telescope is producing now is the survey of the Magellanic Clouds, these green squares over here.
To produce a complete map of the Magellanic Clouds, Ivanov spends a total of 1/3 of every year at a mountaintop observatory. He has already taken over 100 of these trips. His destination is about 1,000 kilometers north of Santiago. It's in an arid zone that sees less than 10 millimeters of precipitation annually. This is the European Southern Observatory's largest site. Seven telescopes are located on the mountaintop here, at an elevation of some 2,600 meters. This is the one Ivanov uses. It's a 4-meter aperture telescope called VISTA. Installation was completed toward the end of 2009. Its technology is cutting edge.
VISTA is a special purpose-built telescope. Unlike other ESO telescopes, VISTA is designed to cover extremely large field of view in a single pointing. The field of view of VISTA is about degree by degree and a half.
How does VISTA compare in this regard to the Hubble Space Telescope? VISTA's field of view is about 500 times greater than Hubble's. In a single pointing, VISTA can take in a region much broader than a full moon. Ivanov and his VISTA team are attempting an exhaustive survey of the entire region containing both the small and large Magellanic Clouds and the bridge linking them. It's sundown. VISTA can now be engaged. In the control room, Ivanov will conduct observations all night long. The display shows stars within the Magellanic Cloud system.
The VISTA Magellanic Cloud Survey already completed a number of tiles, and the data are publicly available. These data contain a lot of interesting objects, like this giant H2 region called Tarantula.
The Tarantula Nebula is an expanse of gas located within the Large Magellanic Cloud. It's 1,000 light-years across. Its name derives from the hairy, spidery appearance of its gases.
This image that we see here actually is built from 3 different images, each of them in the near infrared. The advantage of the near infrared and the advantage of the kind of data that VISTA delivers to us is that we can actually see through the dust. If you look at this area on the sky in the optical, you'll see almost no stars because the dust absorbs the optical light much more than the infrared light.
Vista captured this image of the Tarantula Nebula. Compare it to an optical image showing ordinary visible light. It's clear that the Vista image reveals the stars hidden beyond the gas and dust. The Large Magellanic Cloud is said to contain as many as 20 billion stars. Vista captures them in stunning detail. Innumerable stars, nebulae, star clusters, countless points of light beyond the reach of ordinary optical telescopes, rendered here vividly and distinctly. Vista is continuing to survey the Magellanic Clouds at a level of detail unmatched by any other telescope. The Hubble Space Telescope has shown us how different in shape as well the Magellanic Clouds are from our own Milky Way galaxy. This nebula, in a remote part of the Large Magellanic Cloud, shines with extraordinary luminosity. It's gigantic, more than 30 times the size of the Great Orion Nebula. And out of the dark gas and dust, it is birthing countless new stars. One region in the Large Magellanic Cloud is giving birth to more stars than any other region in the Milky Way. Here is just one portion. Newly born stars illuminate the surrounding gas. It looks like a cocoon. Here, an accretion of gas and dust is displayed in silhouette, lit from behind by young stars. The largest mass looks like a seahorse. It's a huge object, some 20 light-years in length. The Small Magellanic Cloud also boasts magnificent nebulae and star clusters. The explosive birth of 100,000 stars. The energy they put out is said to be 60 times that of the Great Orion Nebula. Or look at the outskirts of the Small Magellanic Cloud. Innumerable young stars, born all in a group. And this sparkling, multicolored, open cluster has been called the Jewels of Magellan. Even today, the Magellanic Clouds are far more prolific than the Milky Way in the production of new stars. The Magellanic Clouds had been thought to be orbiting the Milky Way. But recently, a great discovery was made in that regard. The discovery was made by Roland van der Merel. Van der Merel spent 4 years directing observations of the Milky Way by the Hubble Space Telescope. His goal was to determine the mass of our galaxy, and he found a way to use the Magellanic Clouds to do so.
We thought that if we could measure exactly how the clouds are moving in the sideways direction, we could learn more about the mass of the Milky Way and about the distribution of the mass in the Milky Way.
Van der Merel's group thus observed the Magellanic Clouds directly in order to ascertain the speed of that sideways motion relative to the Milky Way. As a reference point, they chose to use a quasar, celestial bodies that are very far away and so essentially motionless. By using a quasar located beyond the Magellanic Clouds, as seen from Earth, they could measure the cloud's relative motion. They pointed the Hubble Space Telescope in that direction. The anticipated motion of the Magellanic Clouds was minute. It is the equivalent of observing a 1 millimeter movement from 100 kilometers away. That was close to the limit of Hubble's powers of resolution.
And then if you try this with a telescope on Earth, you run into several realistic problems with telescopes on Earth. For example, telescopes are subject to gravity. As the telescope moves, the gravity on the telescope is different, and the instrument distorts a little bit. And you see this in your images.
The observations with Hubble continued for 4 years.
Now, we cannot actually measure the motions of stars in the Magellanic.
Van der Merel's group succeeded in obtaining data on 25 of the regions into which the Magellanic Clouds had been divided. After analyzing the results for a full year, they calculated that the Magellanic Clouds are moving at an incredible 378 kilometers per second, 1.36 million kilometers per hour. This was 300,000 kilometers per hour faster than anticipated.
Initially, we were just very happy we were getting any results out that said, hey, we can actually measure the motion of the Magellanic Clouds. So that was our initial excitement for quite a while. And it was clear we were doing it better than anyone else had done it before, but it wasn't immediately obvious what we were learning.
To extract meaning from these speed calculations, computer simulations were conducted of the relative motion of the Milky Way galaxy and the Magellanic Clouds. The simulations were carried out at Harvard University. The movements of the Magellanic Clouds were minutely calculated, using the latest data on the size and mass of the Milky Way. This is the result. Contrary to expectations, the Magellanic Clouds do not orbit the Milky Way. Assuming the Milky Way is not unnaturally massive, the Magellanic Clouds will eventually fly off into deep space.
I basically computed things like the escape speed, which refers to the speed that an object would need to have to escape the potential of the Milky Way at its distance, at separation from the Milky Way. And for the basic model that I had initially started off with for the Milky Way, the LMC was sitting at the escape speed. So the orbit couldn't be anywhere close to what we thought before.
So it was very normal for people to think for years that the Magellanic Clouds had been going around the Milky Way many times. Gratina realized that that couldn't be at that speed. They were going too fast. They were basically flying away from the Milky Way too fast, which means that probably they were just coming into the Milky Way for the very first time. And this was a very revolutionary thought.
So the Magellanic Clouds are not satellite galaxies of the Milky Way after all. They are visitors from afar, merely enjoying a chance encounter with our own galaxy. In a few billion years, they are fated to disappear into the furthest reaches of space, never to return. The true nature of the Magellanic Clouds is gradually emerging. and astronomical observations indicate that the clouds hold a key to understanding what the universe looked like right after the Big Bang. Paul Crowther is one of the scientists fascinated by the Magellanic Clouds. For 15 years, he's been studying one of the cloud's features in particular. What's attracted his attention is the Tarantula Nebula. At its center, there's a place estimated to shine with the luminosity of 100 million of our suns. R136 is its scientific designation. It was thought to contain a mystery object. Crowther set out to find out what that was. He conducted his observations with what's called the VLT, or Very Large Telescope, located in Chile. He pointed the VLT and its 8.2-meter diameter mirrors straight at R136 in the middle of the Magellanic Clouds. This is the very center of R136. The detailed view provided by the VLT reveals that what looked like one bright clump at its center is comprised of many stars, the brightest of which has been designated R136A1. With a luminosity of 10 million suns, it is, so far as we now know, the brightest star in the universe. Crowther performed a spectral analysis of its light.
The spectrum is kind of like the fingerprint of an object. It tells us what it's made of, it tells us how hot the gas is in the star. And so this actually is an infrared spectrum taken with a very large telescope of R136A1, and it reveals the presence of, for example, this is a line of helium-2, ionized helium, and this means the star is incredibly hot.
Thanks to this analysis, Crowther was able to start profiling his mystery object. This is how Crowther envisions R136A1 in the center of the Tarantula Nebula. With surface temperatures reaching 55,000 degrees Celsius, it burns bright blue. When it was born, it had the mass of 300 of our suns. To date, nothing comparable has been found in the Milky Way. These first-generation stars of the early universe, born right after the Big Bang, were unlike most of the stars we see today. They were formed directly out of hydrogen and helium gases, and they were all blue giants. In the Magellanic Clouds, there are many such stars. The Hubble Space Telescope has captured a number of ancient galaxies that contain these blue giant stars. All these galaxies are more than 13 billion light-years away. So what we see now is how they looked 13 billion years ago. In other words, just moments after the universe was born. Ancient galaxies, glowing bright blue. The the sheer number of blue giant stars, similar to the one Crowther has been studying, is enough to impart a blue color to the galaxy as a whole. These galaxies, born just after the creation of the universe, are a mere tenth the size of the Milky Way and have irregular shapes. In size and shape, they resemble the Magellanic Clouds. That is why scientists believe that studying the Magellanic Clouds will provide insights into the evolution of our own galaxy.
Well, so the interesting thing here is that we've learned a lot about structure formation in the universe over the years. And in particular, what has been learned is that structure forms by smaller units coming together. So if you're a big galaxy like the Milky Way, you really started out as lots of little clumps that fell together over time.
One scenario for the growth of the galaxy would go as follows. In the earliest stage of the universe, there were only small, irregular galaxies like the Magellanic Clouds. These small galaxies collided and merged repeatedly. In this way, so the theory goes, over the course of billions of years, larger galaxies like our Milky Way were formed. Van der Merel believes that the Magellanic Clouds are in fact holdovers from the earliest days of the universe, small galaxies that only now are brushing past our own larger galaxy.
In the early universe, soon after the Big Bang, we believe this happened all the time. There were bits and pieces of galaxies falling together to form the first real galaxies that then later grew over time. Nowadays, in our current universe, this is actually a pretty rare occurrence. So the fact that we're seeing the Magellanic Clouds pass the Milky Way right now is very unusual at some level, but it really gives us a glimpse of what the universe was like more typically when it was much younger, when galaxies were falling onto each other and merging together all the time.
The Magellanic Clouds had been thought of as satellite galaxies. But it turns out that they are actually leftovers from the very beginnings of the universe. Small galaxies linked together, spewing a plume of gases behind them as they rush past us. At the Vista Telescope in Chile, observations of the Magellanic Clouds are ongoing. The detailed mapping of the Magellanic Clouds, based on the Vista surveys, is expected to be completed in 2017.
Vista is continuing the observations of the Magellanic Clouds, and we are extremely lucky to have this exciting and mysterious galaxy next to us, because it has been a wonderful playground for astronomers for more than a century now, couple of centuries, and I'm sure it will help us to reveal many more secrets.
The origins of the universe, the birth of the galaxies. These are the mysteries to which the Magellanic Clouds hold the keys. As humanity peers into the southern night skies, that quest will continue.